One unique feature of Java is that Java contains what are called wrapper classes. Now, the point of a wrapper class is just to allow us to use a primitive type in a place where we would normally only be able to use an actual object. So if you'll recall, in Java, there's primitive variables where the actual value, they're actually stored in the variable itself. And you have reference variables, which don't hold the actual value. Here we have a thing variable that holds this thing that has the attributes 10 and John. In this case, this reference variable only holds a reference to the actual object. There's a level of indirection here, and this is how any object variable will work in Java. The primitive types work a little bit differently, and they're more the way you would see a variable used in, for example, C. So wrapper classes for primitive types, here we have an integer with the value 5, and the value 5 is stored in the memory location for that variable. Here we have R, which is an object of the wrapper class integer, and R stores a reference to the actual object. So you'll notice again, just like we had with the previous object, we have a separate object, and our variable is a reference to that object. So if this is confusing for you right now, it is something that we'll get to later in the semester, so don't get too hung up on it. I just wanted to introduce the idea of why we have these wrapper classes. And so there's two things that the wrapper class provides. Number one, there are a lot of static methods in the integer class that we can use to work with integer values and do some conversions. And we'll see some examples of those. And the second thing is this lets us use a primitive type anywhere that an object is expected. I'll show you a quick example of that. That mostly concerns using generic types, which we'll talk about in a few weeks. So we'll just touch on it very briefly just to show you, hey, this is why we have these things. One other thing I want to point out is here we're creating the integer object using the value of method. The constructor for the integer class is actually deprecated, meaning you shouldn't use it and it may go away sometime at some point in the future. Instead of using the constructor, we'll just say integer.value of 17. In fact, there's no reason I can't just say 17 here. I just wanted to show you this to give you an example of explicitly creating that integer object. So to start off with, I've created a quick main method that has three primitive variables, an int, a char, a double, and we'll actually use the wrapper classes for those. I also created these two strings. These are strings, so they're characters, but you'll notice those characters are the characters of the integer 42, and here we have the characters of the floating point number 6.022. So each of these types has a wrapper class. So let's create a second variable, but the second variable will use the wrapper class. So we have integer num2 is equal to 20. We'll say that character char2 is equal to b, and we'll say that double float2 is 12.34. So now let's print these out. Okay, so now I have some print statements for each of those types. This /t is just a tab character, and I'm using that just to line these up. But I think that I only need the one tab here, so let me take one of those away. So I'm printing out these first 6 variables that I declared. Okay, so you see that everything works pretty much the way that you would expect. So now let's see some of the things that are built into our wrapper class itself. There's a lot of static methods and also constants. We can get the range of integers that are valid on this particular system. And you'll see we have integer.min value, and this will go through integer.max value. I can also convert a string to an integer using the parseInt method. So let me actually, here I have a string saying what I'm doing, then I need to actually call it. And you can see there's that, and my string, I'll do string 1. And let me spell this correctly. I'll copy and paste this and then change this to double, and we'll parse. Let's see, so if I say double, parse double, and let's do string 2. By the way, just so that you understand, there's also a type called float, a primitive type, but I prefer to use doubles. And so whenever you want a floating point, the double has more memory allocated, so it has extra precision. So I'll use doubles anytime I want floating point numbers typically. So now we run this and you can see we've converted that string to a double. And so I could actually, if I wanted to, I could say double new num is equal to double dot parse double string 2. I realize printing that out is not a very good demonstration of what it's doing, but there you can actually see now new num gets that value. So if you're curious about what other methods are there, if you just type integer and then dot, you can see there's a whole lot of methods here. The one thing I would tell you though is just be sure that you read the description. So we have these constants that you can use, and then we have these methods, and then if you click on the method, once it pops up in Eclipse, it'll tell you what it does. So in this case, we get the number of 1 bits. There's some comparison operators and so forth. Another one that may be of interest is if we do use this max function. Let's actually use that. But instead of A and B, let's say 10 and 20. Let's print this out. And then let's do the same thing for min. In fact, let's do min first, and then we'll do max. So again, just another method that is a helpful method that exists in that integer class. And these are all static methods. I don't actually have to create an integer to use them. That's why I have to use the class name instead of an actual object name here. One other nice feature of these wrapper classes is that I can do things like this. So if I say num1 is equal to num1, but then I can also say that it's equal to integer to binary, and that will actually convert that to a string. That's the binary representation of that number. So num is 10, and this is 8 plus 2 is 10. I can do the same thing for octal. And I can do the same thing for hexadecimal. To binary string, to octal string, and to hex string. Those aren't super interesting since it's just 10. So let's put tabs here. Let's see, how about instead of num1, we'll do this larger number, 573,824. So anywhere I have num, I'll change it to that number, and that should give us a more interesting binary string. So here you can see what the binary, octal, and hexadecimal representation. Still a surprisingly small number of ones there, but that's okay. Actually, one way we can guarantee to get ourselves some more ones here, let's add 21 to this. Yeah, now we have some more ones. And I fixed the formatting. So again, something cool you can do just to do conversion back and forth. Now, we have these neat tools, but that has, you'll notice we actually haven't done a lot with actual objects of these wrapper classes. Where are these useful? Well, one thing I can do is suppose I write a method called add10 that takes an integer, and it's going to return x plus 10. So if I add 10 to 1, and let's run this and see what happens, you can see that I get 11, which is what I would expect. Now, let's do num1 and num2. And remember, num1 is an int, num2 is an integer. And you notice those both work as we would expect. Now the thing to keep in mind here is this is taking an object of integer type. And what's going on here is when I pass a primitive int, it gets auto-boxed into an integer object and passed there correctly. Now where that's really helpful, and this is something we'll get to later in the semester, is when we start having generic data structures that are going to hold objects. Since in Java we don't have object variables, we have object reference variables, our data structure itself is going to have a bunch of references to some objects, and that's what's going to be stored in the data structure. Well, these objects are going to be what are called a generic type, and that generic type will stand for whatever the type of object we want to store in that specific data structure. So again, this is something we'll cover in a few weeks. If it's unclear right now, I just want to motivate really the big reason we need these wrapper classes. This is going to be a generic type, and when we create a data structure, we have to specify which type we want to store in that data structure. So let's do that. Let's create an array list. Now, array list, you have to specify what sort of type you're going to store in it. So let's say I'm going to have an array list of strings. So there we go. And I need to import array list. Okay, so I'm importing that, and that should make that go away. Now, suppose I want to have a list of integers. There I'm getting an error. It knows what an array list is, so it's not because I'm not importing it. And here you see syntax error, insert dimensions to complete reference type. Well, the problem is that int isn't a reference type. It is a primitive type. And so if I want to have an array list of integers, I need to put integer there instead, because the integer class wraps an int. You'll notice now this will let me do this, and I can go ahead and add actual integers all day long here. You'll notice I'm passing in integer literals, which get auto-boxed into an integer object and then added to the specific data structure that we're interested in. So again, that's a quick introduction to wrapper classes in Java.